Okay, we're doing a couple problems here. This is number 7 from 7.2. It says find the points on the curve that x equals t squared minus 12t plus 8 and y function is t squared plus 4t minus 9. And the way we do this, to find the vertical tangent that occurs when x prime of t equals 0. So x prime of t is going to be 2t minus 12. So 2t minus 12 equals 0 whenever t equals 6. So if we plug that back into the two original equations, we would have x of 6 being 6 squared minus 12 times 6 plus 8. So it's 36 minus 72 plus 8, and that gives us negative 28, which is this value here. And then y of 6 is going to be 6 squared plus 4 times 6 minus 9, and that gives us 51, which is here. So that's why this is negative 28, comma 51. For the horizontal tangent, that's where y prime of t equals 0. So y prime of t is going to be 2t plus 4. So 2t plus 4 equals 0 when 2t equals 4, or negative 4. T is negative 2. So we plug that negative 2 into each of these equations. So x of negative 2 is negative 2 squared minus 12 times negative 2 plus 8. And that's going to be 4 plus 24 plus 8. That's 36, which is this value. And then y of negative 2 is going to be negative 2 squared plus 4 times negative 2 minus 9. And that's going to be 4 minus 8 minus 9 is negative 13, which is this value. So that's why we get 36 comma negative 13. Now let's go on and look at number 10. Actually wondering if I have enough room for this because I want to do 12 on the same thing, but let's just go forward. So it says find the area of the region bounded below by the x-axis and above by the curve. We have our x and our y. Our formula for this is the area is going to be integral from, in this case, 0 to 2, pi over 2, of y of t times x prime of t dt. So our x prime of t is going to be 2 times, the derivative of sine squared is 2 sine theta times cosine theta. So we put this all together. We have the integral. I gave you the answer here. From 0 to pi over 2 of 3 sine squared theta tangent theta times this 2 times 2 sine theta cosine theta d theta. And if I clean it up a little bit, I have 0 to pi over 2 of, what do I have? 3 times 2 times 2, so that's 12. I'm just going to pull that 12 out front. So I'm going to clear that off. We have 12 integral from 0 to pi over 2. Not a very good integral, but whatever. Of, now I have a sine squared here, I have sine here. So sine cubed theta times, and tangent is sine theta over cosine theta times cosine theta d theta. And as you see, these cosine thetas just divide out. So what we really have is the integral from 0 to pi over 2, got that 12 out front, of sine 4th power theta d theta. So there are a couple ways to go about this. I use a table of integrals, and there's the formula breaks down to be, still have this 12 times 3/8 x minus 1/4 sine 2x plus 1 over 32 sine 4x. And we're evaluating this from 0 to pi over 2. So we're going to have this 12 times 3/8 times pi over 2 minus that 1/4 sine of 2 times pi over 2. Well, 2 times pi over 2, that cancels, so it's just sine of pi, which we all know because we memorized our values. Sine of pi of 0 is 0, plus 1 over 32 times sine of 4 times pi over 2. 4 times pi over 2, that just makes this into a sine of 2 pi, which is, again, you'll memorize the value, so that's 0. And then minus 3/8 times 0. Minus the negative makes that plus 1/4 sine of 2 times 0. Sine of 0 is just 0. That's 0. And then we have minus, or minusing here, so it's minus 1 over 32 sine of 4 times 0. Okay, and sine of 4 times 0 is just that sine of 0, so that's 0. So all we really have out of this is right here. So we have 12 times 3 over 8 times pi over 2. And the 12 and the 8, you can reduce the 4 out of those. And we have 3 times 3 is 9, pi over 2 times 2 is 4. And that's what we get. Okay, hope that helps.